Here we're trying to decide if the square root of 59 is closer to 7 or 8. Think about what 7 is squared. 7 squared is 49, so the square root of 49 is 7. And the square root of 64 is 8. So 56, that's closer to, 59 is closer to 64 than it is 49. So the square root of 59 is closer to 8. If you need to, you can subtract to 59 minus 49. You can see that it's 10 away from 49, and then 64 minus 59 gives us 5. So it's closer to so the square root of 59 is closer to 8. 96, same type of thing. Square root of 81 is 9. Square root of 100 is 10. 96 is closer to 100, so the square root of 96 is closer to 10. Number 3, we got square root of 28. Again, we're doing this without a calculator, trying to figure out which is closer to 5 or 6. 5 squared is 25. 6 squared is 36. So the square root of 36 is 6. So square root of 28 is closer to 5. Number 4, the negative square root of 121. So the negative sign stays in front. Square root of 121 is 11. So we get negative 11. Number 5, positive square root of 144 is 12. Because 12 times 12 is 144. Square root of 300, it's not a perfect square, but you can think of 300 as 100 times 3. Write it as factors. 100's perfect square factor. The square root of 100 is 10. So we have 10 times the square root of 3. You can do it that way, or some people may not see that 100 is a factor at the beginning, so they could just start by doing a factor tree. So 30 times 10 is 300. Come up with factors of 30, 3 times 10. For 10, 2 times 5. And another 10, 2 times 5. So the ends of our factor tree, those prime numbers, give us the prime factorization. So we've got 2 2's or 2 squared, 2 5's or 5 squared, and then also a factor of 3. So instead of writing the square root of 300, we could write the square root of 2 squared times 5 squared times 3. Square root of 2 squared is 2. Square root of 5 squared is 5, and then we have the root 3. So that gives us 10 root 3. So whichever way you work it, you still get the same answer. 17, square root of 17 times square root of 17. You could rewrite it as the square root of 17 squared, or just 17. And 17 squared, by the way, is 289, but then when you take the square root of it, you do get 17. Number 8, trying to simplify the square root of 128. 128 is not a perfect square, but it is the same as 64 times 2. Square root of 64 is 8, so we have 8 square root 2. If you didn't realize that 64 was going to be your perfect square factor, you could have done the factor tree. Still might have started with 2 and then divided that by 128 divided by 2 gives us the 64. You might keep on going, 8 and 8, and 2 and 4. Factors of 4, 2 and 2, and 2 and 2. So we end up with 1, 2, 3, 4, 5, 6, 7 factors of 2. So if you wanted to, you could write it as the square root of 2 squared times 2 squared times 2 squared times 2. Again, we're looking for those pairs of factors because we're taking the square root. Square root of 2 squared is 2. Square root of 2 squared is 2. Square root of 2 squared again is 2. So if you multiply the 3 numbers in front, 2 times 2 is 4 times 2 is 8. So you get 8 square root 2. So you can do it a little bit quicker if you think of the perfect square factor, but the factor tree is always there in case you don't think of that biggest perfect square factor. Number 9, adding 5 square root 7 plus 8 square root 7, you get 13 square root 7. You can think of those as adding radicals. It's the same idea as adding like terms. 5x plus 8x would give us 13x. Same idea. We have the square root, both of them have the same index, and we have the same number underneath it. Number 10, 2 square root 6 minus 5 square root 6 give us a negative 3 square roots of 6. Again, same type of idea as 2x minus 5x, which would give us negative 3x. Number 11, we're adding radicals, but they're not like radicals, so we've got to make some adjustments. We've got to change something until we can get to like radicals. So let's work on this 20. 20 could be rewritten as 4 times 5. And the square root of 4 gives us 2, so we have 3 times 2 times the square root of 5 plus 8 square root of 5. 3 times 2 is 6, so we have 6 square root of 5 plus 8 square root of 5. Now that we have like radicals, we can add those together. 6 square root of 5 plus 8 square root of 5 gives us 14 square root of 5. Number 12, we're not adding, we're multiplying. So we're going to multiply the numbers in front. So 5 times 3 gives us 15. And then underneath the radical, we have 32 times 2 gives us 64. And then square root of 64, that's 8. And then 15 times 8, if you don't know it, you can multiply. 8 times 5 is 40. Write 4 down. 8 times 1 is 8 plus 4, 12. So we get 120. Notice that there's no square root in our answer.